few videos back, we learned how to solve equations like the ones you see written here on the slide. And the way we did that is by using a radical to cancel out our exponent on x. So for example, we would have done a square root on both sides of this equation, a cube root on this one, a fourth root on that third problem down there. And that worked out just fine. And if you like doing that, you can continue to do so. But I want to use this chance to introduce a new way to express radicals. Instead of doing like a root on both sides here, what I'm going to do is use an exponent on both sides. So like I'm going to raise both sides to a certain power. Instead of doing a root, I'm going to put an exponent here and here. And if I do it to both sides, I'm allowed to do that. My ultimate goal is that I want to solve this equation and get just regular x for my answer. Which means, in other words, I want x to the first power. So what I need to ask myself is, okay, when my exponent's out here, I'm going to multiply my exponents together. 2 times what number will get me 1, like I want to have? And it turns out that the answer is 1/2. If you do 2 to the times 1/2, so if you take x squared to the 1/2 power, 2 times 1/2 is just 1. So what we really need to do here is do 81 to the 1/2 power and see what that equals, and that'll be our answer to the problem. So when you actually type in 81 to the, and in my exponent, I'm just going to put it all up there. If you have an older calculator, you might have to put the exponent in parentheses, but here you can see very clearly that that's all up in the exponent. When I type that in the calculator, it says 9. And knowing that it was an even power there, I know that plus or minus 9 is going to be my full solution right here. So it's kind of interesting, but it looks like on this problem that when we did a number to the 1/2 power, that was the same thing as doing a square roots. Test it on another number here. Let's say I did 100 to the 1/2 power. You'll see that you do get 10 like you would expect if you did a square roots. So on the side here, we're going to make like a little box with our kind of note for ourselves here. Oops, it's not a very good box. X, let's see, the square root of x is the same thing as x to the 1/2 power. So when you do a number to the 1/2 power, it's the same thing as doing a square roots. On my next example here, I want to cancel out this third power, and before what we did is we did a cube roots. Well, I'm going to go ahead and do a 1/3 power, because if I multiply my exponents here, 3 times 1/3, I'm going to get just x to the first equals, and I got to do the 1/3 power of 125. And if I type that in my calculator here, you'll see it does equal 5, same thing as cube root of 125. So if you take the cube root of x, that's the same thing as x to the 1/3 power. And hopefully you guys are starting to see the pattern here. We got one more to go on this though. If you do both sides to the 1/4 power here, 4 times 1/4, those are going to cancel to get you x to the first. And 16 to the 1/4, I won't even show this one, it does equal 2. So the fourth root is the same thing as the 1/4 power. Of course, on this one, I would need the plus or minus, since it's an even index. So the fourth root of x is the same thing as x to the 1/4 power. The fifth root of x is x to the 1/5 power. If you have a fraction exponent where it's 1 over a number, it's the same thing as just doing that type of root. That's kind of important. To practice this and put it in action, I have a couple examples here where we're just going to convert back and forth between having radicals and having fraction exponents instead. So the first two problems ask us to rewrite using rational exponents. Rational exponents. Rational essentially means fraction. I mean, there's more to it than that. We've gone into it, but when I hear the word rational, I picture a fraction in my head. They want you to write this with exponents that are fractions. And remember, this cube root right here is the same thing as a 1/3 power according to what we just discovered. So what I'm really looking at here is that thing to the 1/3 power. And then what I can do is I can distribute my exponents and use my exponent properties, and I will end up multiplying that in. I'll get x to the 2/3. 5 times 1/3, it'll be y to the 5/3. And z, it'll be to the 6/3, which is just z squared. So this guy right here in purple is the exact same thing as this. They're just different ways of writing it. On my next one here, that's the same thing as really that stuff to the 1/4 power. So I'm going to get x to the 6/4, y to the 4/4, z to the 11/4, which I can then simplify. I'm going to get x to the 3/2 by reducing y to the first, and there's not much I can do with z to the 11/4. So I can rewrite my problem again with fractional exponents. Sometimes you may want to go the other way. So here I have 3 examples of problems involving fraction exponents. So what kind of is a little bothersome on this one here is that the fractions are not all the same denominator. This I'm going to change right here and make it to the 2/4. It was 1/2. It's the same problem. I'm just editing it to make it look more like understandable here. So really what I have here, if they're all over 4, that means I was doing the 1/4 power. So I really have a 4th root here, and then it would be x to the first, y to the second, z to the third. Because if you actually multiply the 1/4 in, you'll get back to where you started. On this last one, I have I have all this stuff and I have a 1/2 out there. That's the same thing as just a plain old square root. And this one is actually a little easier. I don't even have to do that extra step. I'm just going to toss all this stuff inside my radical. These mean the same thing. So going back and forth between these forms is something that will become more into play if you go into more advanced math classes, but hopefully you can see how it's done.